So we already did a quick overview of the three different types of similarity reasons we can state. Let's go over them one at a time and show you how to prove similarity. So if you look at number one, I know these lines are parallel. So you know if you have parallel lines cut by transversal, I can claim alternating interior angles are congruent. I also know that these guys are vertical angles. So these two angles are congruent to these two angles. So yes, I can claim they are similar. And my statement is that Big Daddy statement that I need. So I'm going to go from 1 to 2 to no tick marks. So I'm going to say CED is similar to triangle 1 to 2 to no tick marks, GEF. So that's my similarity statement for number one. Look at number three. I know that these two angles are congruent, but I don't know these two angles are congruent. Don't lose sight of common sense. You can figure out this angle right here. We know they're 180 degrees in a triangle, and so just for the sake of confidence that we need to know, find that missing angle. So these two have to add up to 90, so this is going to be 51 degrees. These two have to add up to 90, so this is going to be 39 degrees. So yes, in fact, these are similar triangles, but if you just went off what was given to us, you may have said no. Make sure you finish it out. So now, yes, they are similar, and my triangle similarity is I'm going to go from E to S to Y is similar to 39 to 51 to the right, so it's HWC. Remember, that order is so, so important. So that's looking at angle. Let me go up a little more. Let's do another angle one. You've got two triangles here. You got this larger one and this smaller one that's inscribed in the larger one. So I know that they're 180 degrees in a triangle. So I know if I add all these up, these guys are going to be 180. So that's 158. So this has to be 22 degrees for this angle piece right here. I know 25, 67, and this angle all need to add up to 180. So 67 and 25 is going to be 92. So I know that this guy is going to be 88. Right? 88. Yeah, 88. So if I do corresponding angles, 88 and 91 do not correspond to each other, and 25 and 22 do not correspond to each other. I mean, I know that angle N is going to be congruent to angle N, but no other angles match up. So no, these are not similar to each other because my angles are not the same. Let's talk about side. Side. Again, they're all proportional. Don't be lazy. You have to check every single side to see if it's proportional. So we look for that aspect ratio after we set those proportions up. So here I'm going to go from the small side to the small side. So I'm going to do 9 over 14. The medium side is 13.5, and I'm going to put it over the medium side here, which is 21. The long side is 20.25, and I'm comparing it to the long side of 31.5. So all I'm doing is I'm finding that aspect ratio. I'm going to grab my calculator. And I am simply going to type these into the calculator. 9 divided by 14, and I come up with 0.64285. I don't need to round that much. And then I'm going to do 13.5 divided by 21, and I get the aspect ratio of 0.64285, and so on. And then I'm going to do 20.25 divided by 31.5, and I get 0.64285. They're the same aspect ratio, so yes, these are similar to each other. And my Big Daddy statement, I'm going to do KNR is similar to triangle. Now I went from small, medium to large. So I'm going to go small, medium to large, and it's DES. That's my similarity statement. Yes, they're similar, and that's why. Okay, let's look at a couple other sides. Let's look at 9 and 10. Right? So I'm going to go from small side here to small side here, which is 4. medium side, which is 12, to medium side, which is 7. And my larger side is 16, and my larger side is 10. So I've set up my proportions. Now I'm just going to type in my calculator, 5 divided by 4, and I get 1.5. I can even keep it on the same screen, and I don't have to write it down. And then I'm going to do 12 divided by 7 and 16 divided by 10. You will notice that all three came up differently. So my aspect ratio is not the same. So no, these are not equal. These are not similar. Not similar. Now look at number 11. I'm asked to prove this with side, side, side. I don't have this side, and I don't have this side, but I do have a right triangle. So can I find that side? Yes, you sure can. Pythagorean theorem. So 5 squared plus x squared equals 13 squared. And over here would be 9 squared plus 21.6 squared equals x squared. So once you do the math for Pythagorean theorem, which we're not going to go over because we already know that, I'm just going to tell you the value of yx here, hang on, is going to be 12. And the hypotenuse of RV is going to be 23.4. So my first step in proving these similar is you got to find all the sides. Now I can set them up proportionally. My small side over here is 5. My small side is 9. My medium side is 12. My medium side is 21.6. My hypotenuse is 13. My hypotenuse is 23.4. And I'm simply going to type all of them on one screen in my calculator. 5 divided by 9, 5 divided by 9, 12 divided by 21.6, and 13 divided by 23.4. And you can see that they all come up the same. My aspect ratio is the same. Yes, they're proportional. So my similarity statement will be triangle ZYX is similar to triangle. I went from small to medium to large. So I'm going to go small to medium to large, and I get RWV. That's how I'm proving triangles similar with side, side, side. Now let's take a look at the last option. And my last option is side angle side. So we want to determine if these are similar. Remember, your angle has to be inside those side measurements. So you can look here and you know that these are congruent to each other because vertical angles. So when I do, now I just need, I know my angle is congruent, vertical angles. I need to test, are my sides proportional? So I'm going to do the small side of my small triangle over the small side of my large triangle. And I want to compare that to the medium side of my small triangle to the medium side over here. And I'm just going to type in 6 divided by 24 and 12 divided by 48. They are the same. My aspect ratio is the same. So it checks out. They're similar triangles. Yes, they're similar. And I'm going to do triangle SRE is similar to triangle. So I went from the blank side to the small side to the medium side. So blank side to the small side to the medium side is going to be GFE. So make sure all your angle measurements correspond. Okay, let's take a look at number 15. These lines are parallel cut by transversal. So I know that these guys are going to correspond to each other. So those angles are congruent, and it is inside those two side measurements. So now good, I'm in a good position. I can compare. I need to see, is 54 proportional to 33, because it's the long side and long side, and is 36 proportional to 22, the small side and the small side. So I'm going to type in 54 divided by 33 and 36 divided by 22. They are the same. That aspect ratio is the same. So yes, these are similar, and they are similar by, I'm going to say triangle CMP is similar to triangle RPQ. Okay, so that's my similarity statement for number 15. All right, let's take a look at number 17. All right, so here are my two triangles. I have a small one and I have a large one. I know these angles are congruent because it's the same, so I don't need to worry about that. I am going to see is 15 my small side proportional to the long side, which is 45, right? Because it's the whole length. So small over the long is 45. I don't know if it's a mid-segment, so you got to be careful there. You can't say that they are equal because we don't know. And I'm going to compare that to 14 over the long side, which is 42. And now I'm going to type in 15 divided by 45 and 14 divided by 42. And I get the same aspect ratio, so they are similar. So now I can say triangle WQR is similar to triangle WSZ. WQR and WSZ. Yes, that is correct. So that's how those work. If you have questions, come see me.